Okay, Year 12, let's have a look at example 3b and we can see how we can again use the result from our reference sheet to assist us with finding the result for this indefinite integral. Why? Because again, we've got this function here inside where f of x is equal to x cubed plus 7, and we've got a function being raised to a power, and outside this function, we've got the derivative of the function, because if we look at this function inside, the derivative of it is 3x squared. So can you see we've got it set up exactly like this, where we've got a function raised to a power and the derivative of this function inside the brackets is out the front here. That's why we can use this result straight from our reference sheet. So let's have a look at what this will give us a result for. We can go straight to here where we've got it in the form of our function, which is x cubed plus 7. Now we're going to raise it to the power of n plus 1. Previously the power was 4, so add 1 to that indice and that becomes to the power of 5 all over. So we've got it in the form now, f of x to the power of n plus 1. Here's our function to the power of n plus 1. All over n plus 1, which is 5, and then plus our constant c. Let's do a double check to make sure that when we integrate this, we get this result. That means that when we differentiate this here, we should end up with this original result here that we started with. So let's look at d by dx of x cubed plus 7 to the power of 5 over 5 and see what that will give us. Okay, let's bring the 5 down to the front, so it becomes 5 times x cubed plus 7. When we differentiate, remember we take 1 away from the indices, so this becomes to the power of 4. And then this is a constant multiplier, so that will remain there. Don't forget, then we need to multiply it by the derivative of what's in the brackets here, which is 3x squared. Now you'll notice that these 5's will cancel, and then our final result will therefore be 3x squared outside x cubed plus 7 to the power of 4, which is our original result that we started with integrating back here. So this was just a check to see that when we differentiate this result, we actually do end up with our original integral. Hopefully all of that makes sense to you. Please take the time, if you need to go back and watch the video again before you start to take notes on it.